In this video, we're going to look at creating a prediction interval for data. A lot of times on television or in the news, you'll see the result of some sort of a survey, and you'll notice that it will say something like plus and minus 3% error. And that's exactly the kind of thing we're going to look at. So before we begin, let me draw a picture of some things. I need some preliminary information before we get there. So let's take a look. And suppose I have drawn the linear regression line. If you remember, that looks like y hat equals mx plus b. All right, and let me put some points on the line. One point that is guaranteed to be on this line is the point x bar, y bar. If you remember, straight underneath of the x is where the x's are on the x-axis, and if you go straight to the left to the y-axis, you'll get to the y value there. So x bar, y bar, that point is actually on the line itself. Now let's pick a point. Let's call it, let's just use x1. This will work for any xi, but let's suppose that I have a point, let's say it's up here, and that height, let me try that again, that is x1, y1. So you notice it's not on the line in this case. And then y1 off to the left, I'll mark it off. So I've got my x1, y1. And also while I'm here, on this line here, you have x1, comma, y1 hat. Remember, the y hats are the line itself. So that's why that point would be on there. So we're going to take a look at a little breakdown of some things. If I look at the distance all the way from here to here, that's y1 minus y bar, from all the way up there to all the way down there. y1 minus y bar is called the total deviation. And now while I'm at it, let me mark off some other y values. We have y1 hat is there. So then the distance between there and there, that of course is y1 minus y1 hat. That has a name also. y1 minus y1 hat is called the unexplained deviation. And there's another distance I want to look at, and that's the distance here. That was y1, and then y bar, y1 hat, and then y bar. That's another distance I would like to look at the difference. y1 hat minus y bar, that goes from there to there. So y1 hat minus y bar is called explained deviation. And if you read through the book, they'll tell you that it's possible to explain that little piece of error, if you want that little piece is off the line, as some sort of a relationship between the variables x and y. So if x was a before and y was an after, for instance, there is some sort of an explanation between those relationships that they understand. The unexplained, of course, they cannot give an explanation for why that happens. Now, we'll not be in the process of determining why something is unexplained or why it's explained. We're just going to specify which is explained and which is unexplained. Then we have variation. Note, if I take the total deviation, so I do y1 minus y bar, and simply put in a y1 hat, then you'll notice that I have this breakdown. On the left, y1 minus y bar was the total deviation. In this piece here, y1 minus y1 hat was the unexplained deviation. And then y1 hat minus y bar is called the explained, well, that's the explained deviation. Now, let's move on to variation. Now, if I look at the sum, I'm going to square these to keep them all positive. I'm not going to do y1 minus y bar. I'm going to do y sub I minus y bar squared. This is called the total variation. I'll underline that. And then similarly, if I do yi minus yi hat, square those, that'll be the unexplained variation. And then finally, if I sum up all of the yi hat minus y bars, that is the explained variation. It just so happens that the following is true. If we sum up all of the unexplained variations, that's the sum of the explained variations. Oh, I missed a square up there. Let me put the explained verse. And then let me put the unexplained next. And there we go. So we have the total, and then we have the explained, and then we have the unexplained. Next, we have the coefficient of determination. And that is r squared. And r squared equals the explained variation divided by the unexplained variation. Note that this is the same r that we figured out as the coefficient of correlation. Next, we have a definition. The standard error of estimate that we note by S subscript E, and that follows this format. So that part, which was the, let me see what we have there, the yi minus yi hat is the unexplained variation divided by n minus 2. Whenever you see that, you can pretty much be guaranteed that the degrees of freedom are going to be n minus 2. All right, here we have an example. Let me first get in the data that we need, and I'll show you exactly how we enter and what data that we need to enter. So for this, I'm going to set up a column of x's, then a column of y's. Let's call these xi, so that they go through I equals 1 to however many there are. In this problem, there'll be 10 of them. Then I want yi hat. I want to calculate that. And then I want to do yi hat minus yi. And then I want to do yi hat minus yi squared. So let me go ahead and get in the information that's given in the table here first. Okay, now that we have that information in, let me get y hat. Remember, that's the linear regression line. So to get that thing, we can pop into our calculator. Let's go to stat, and we want to choose number 1 for edit. That's good, perfect. And now let me get my data in. Remember, you can delete your way through the data if you need to get rid of what's already there. So I'm just going to hit the delete button over and over again until it's all gone. And now let me put in my actual data. All right, once we have this in, now I can go ahead and get my linear regression line. If you recall, the way to get that is that we go into stat, so press the stat button, and then you want to go over to calc, and then go down to number 4 for Lin Reg. Let's go ahead and hit that, and you can enter your way through. And there we have, I'll just go to 3 decimal places as needed. It looks to me like we have our y hat. Let me write that down. So I've gone to 3 decimal places. Now, what I want to do is I want to take each of these xi's and plug it into this formula. You'll find that there is a very nice thing built into your calculator for this. Let's go to my y equals. Let me clear out what's there. And let's put our new linear regression line. So I can go 1.005 x minus 10,770.313, and I'll enter. So now that's locked away in there. What I'm going to do is let my calculator compute this next column for the most part for me. I have to plug in each of these x's into this formula here. And the easiest way that I can think of doing it is to leave this completely. All right, start with the 50,976. I'm going to store that in for x. Hit enter. Now that's stored. Now go to vars, choose yvars, leave it on function, choose enter because y1 is where we have the formula, and we get 460. 0.567. Now what I'm going to do now is calculate the rest of these while I have this number here. While it's there, it's very nice. Now that I have this number here, I can subtract off the 40,214. So all I have to do is press minus 40214. Enter. I get 246.567. Now I have to square that column. So all I do is come back to the calculator and hit the square button, and it will square my answer. I get 60,795. I'm going to round everything to 3 decimal places. Actually, you know what? I think I'm going to go 4 decimal places because I'm going to use these in calculations later. I usually like to go 1 more decimal of accuracy than what the final answer requires, if I can. So 6795. 0.2855. And then I move on to the next data point. So this time I'm going to put in my 46763. I'm going to store that in for x, like so. Go to vars, yvars, function y1, enter. 36226.502. Now let me get y hat minus y. So I'm going to subtract the 36,834. So minus 36834. Here I get negative 607.498. And then press the square button. Notice it'll also take care of the negative for you while you're there. 369,053. .82. Once again, come up. 46934. I'm going to store for x. Store it into x. On my vars, yvars, function y1, enter. 36398. .357. And then continue the rest of the calculations. Let me subtract 36,841. I get negative 442.643. And then I will square that. 195,932. $8,254. And then I'll just go through and quickly throw in the rest of them. You can slow down the video because I'll inevitably speed it up to make these calculations go faster. And that way you won't have to sit here. Well, I guess you could always fast forward if I were to go slower, but nonetheless, let me go ahead and put in the rest of the data. All right, now that that's all done, we are now finally prepared to get this column here. Add up this whole column. Now we're finally ready to answer this S sub E. Now, what we have is step one in computing an interval. We have actually found just one possible thing. I need another piece of information yet before I'm able to start making up my intervals. So these form prediction intervals. And what we want to do, we said that the x and y's form a bivariate normal distribution. What that means is if you hold one variable fixed, the other variable forms a normal distribution. The way you might see it, like, I guess one way to take a look at how this might look is, let's suppose we have our linear regression line. That's always what we're kind of measuring things from. Remember, that is mx plus b. And suppose I pick one of the xi's, let's call it just x1 for now. Well, if you remember up here at this point on the graph is x1, but the y is y1 hat. Well, what happens is, if we also look at, I don't know how I want to put it here, but let me do this. I somehow want to make a little normal distribution. I wish this thing would stop doing it. I want to make a normal distribution from this little tippy point here, like so. So in the center of that normal distribution is supposed to be, it's supposed to be centered at y1 hat. So if I had another x value, I don't know, let's call it x sub I. At this point on the line, we have x sub I, and then we also have y sub I hat. And so about that, let me see if I can draw this adequately. We have a normal distribution about that one there. And that's, of course, where xi is being held fixed. So we'll always make that assumption anyways. It's more difficult, obviously, if you're the one doing the statistics and then you have to try to determine if this is true or not. So, to create a prediction interval, we use the t distribution with the degrees of freedom equal n minus 2. And then the interval is going to look like this. One way of writing it looks like y hat minus e less than y hat plus e. Or in interval notation, you might think of it this way. So that y is the center of this particular interval. And now let's get what e is equal to. E equals t sub c times s sub e times 1 plus 1 over n plus n times x naught minus x bar squared all over n times the sum of x squareds minus, first I'll sum the x's all up and then I'll square it. And then all of that is under the square root sign. So let's create a prediction interval for this particular problem. Now, let's do what this says here. Exercise 12 happened to be the exercise that I pulled up at the beginning. This is a continuation of that exercise. We want to construct a 95% prediction interval for the median annual earnings of female workers when the median annual earnings for male workers is $45,637. So if we know the males make that on average, what are the range of possible pay that females can get. Plus and minus, well, it won't be plus and minus 5%. It'll be plus and minus 2.5%. We have to divide our alpha into 2. So we can see that alpha equals 0.05. So I'm going to use alpha over 2 equals 0.025. Now, I'm only interested actually in the right-hand side of this thing. So I'm going to get rid of that. I don't really want it. And what I do want, though, is that piece, because this makes this piece is 0.975. And so T sub C, I'm interested in that T value. That's this guy right here. And so you've done this 100 times. We can use our calculator, you can use your tables, I really don't care. But you have to specify the degrees of freedom, and you have to specify this or this piece, depending on if you use the table or your calculator. I am going to do it with my calculator. So remember, whenever we want a critical value, that's inverse T. So I'm going to go to second vars. I want number 4. And it's going to require my area, so I'm going to put 0.975. And the degrees of freedom, as we've seen this before, if you don't even want to calculate, you can put 10 minus 2, and then enter your way through this thing. It doesn't like what I did, probably because I put a minus in there, minus, and a minus. 2.306. And then the S sub E, we just did that one. Now we need this big square root. Let me grab that. And now let's see what I have. 1 plus 1 over 10 plus 10 times. Now the x naught is exactly what they were talking about. This here was the thing, this is if I'm assuming that men are making this kind of an average, what is the range of values that a woman would be expected to make? So 45,637 goes into x naught. Minus, let me grab x bar. That will be in calculations, and I can choose my number 2 and then just enter my way through this. Let me get my x bar is 48406.3. Now let's get our sum of x squareds. That should be somewhere in there. I can get it if it's not there. It is. I don't like the looks of that, do I? Well, now, what are you going to do in a situation like this? Because if I write this, there will be a lot of rounding that occurs. If you put that number, if you put exactly what you see here into here, there will be rounding. So instead, what I'm going to do is this. I can grab this exact answer by going to vars. And then I go to 5 for statistics. And then I go to these sigma ones, and there, see it there? Number 2. So, in fact, let me do this. Let me move back to here. So instead of doing all this, I am going to write it underneath of here and watch how I do it. I'm going to use my calculator to do all of this for me. Let me first quit this. So I need to have 10 for my n, so I'll do my 10. Now I need a times. Now I need this sum of x squareds. So if you go to vars, then choose 5 for statistics and then move over 1 to that sigma there, choose number 2. And then I don't even have to put the sum of x's in here. What I can do is put in parentheses, go to vars, choose number 5 for the statistics ones, go over to sigma, and then choose sum of x number 1. Finish it off, put the square, and let's enter. 279, 261, let me see where, 279, 261, 1421. And, you know, when I was a kid, they told us to start from the right. That way you knew the correct number of digits to have in there. And let's go ahead and calculate what this number gives us. Now we are ready for our computation. So we have TC, SC, and we have this thing. So E is approximately equal to 2.306 times 1396.779 times 1.0618. You'll only need 2 decimal places since we're talking about dollars and cents. So now what we can take is take our y hat, which we had. I don't think we actually did y hat just yet, did we? We have y hat equals the 1.005 times, now the x value, the x sub 0, if you will, that we were given, 637 minus 10,770.313. And what do we get for that? I'm going to round to 2 decimal places, so 35,094 0.87. So we're going to add and subtract from that this e value. So let's call it the left endpoint, whatever you want to call it, left endpoint, I guess. We are going to have 35094.87 minus 3420.03. $31,674.84. And then the right endpoint, this time we're going to do 35,094.87 plus that same number. $38,514.9. So then our interval is this. We will go from our prediction interval. So with 95% certainty, when a median annual salary for males is, let me find out what that median number was, 45637. The median annual salary for females is between $31,674.84 and $38,514.90. All right, let me do an example that will use the calculator almost completely So I'm going to cut down quite a bit of work by allowing the calculator to do everything. And so in this example here, first what I want to do is find r squared and find s sub e. So compute r squared and s sub e. So let's start with that. Let's get into our calculator. And let me go to stat. Let me see how many pieces of data we have. It looks like 6. I have a total of 11 pieces of data. So let me edit. I think last time I only entered 10 pieces of data, so I think this time I can put in the data and it will overwrite it completely. Alright, now that I got my data, there's really only one place we need to go for everything that I was just telling you. I can go into just press stat. Go over to tests. Now, if you scroll down, you can scroll down if you want, as far as you want to go, to letter F. This is called the Lin Reg T Test. So once you get what you want, enter your way through. Of course, we want L1 and L2. Now, if you try to enter your way through, watch what happens when I hit enter. It sticks me on this. I can't enter my way through it, so I have to come down until I get to calculate. Now hit your enter. And what it does is it gives you everything that you need to know. Let's take a look here. It actually, this line y equals a plus bx is the linear regression line. The problem with it is that a and b are switched from the other thing that finds the linear regression line, so you have to be careful. If I go down, you can see my the y-intercept is 410 and the slope is 0.459. So let's round it to 3 places. Let me get the linear regression line. So as I said, be very careful here. A is the y-intercept and B is the slope. That's switched from the other screen that we use. So let's go ahead and put that down. We have y hat equals, let me get my B first because that's my slope. There it is. I'm going to say 0.460. And then I need the y-intercept, which is the letter A here. So I'll do 410.839. Got it. So this gives me, and you can see that it is the same as the one here, to 3 decimal places, that is. But that screen gave us a lot more. If you scroll down even farther, there, see that letter S? That S is our S sub E. That's 55.608. So our S I'm going to 3 decimal places here. Usually, actually, I think I'll go to 4. Let's go 55.6076. I like that better since I'm using it in a calculation later on. So 6076. And I can even get r squared from that screen. Keep scrolling down. See, there's r squared, and it will even give us r. All of that stuff's there. To 4 decimal places, r squared is 0.8942. Remember what that means. That means that 89.42% of the variation is explained. 1 minus that is unexplained. Now, what Now that we have this information, we're going to use it to build a prediction interval. And you remember the way it looks is something like this. E minus some amount. Well, actually, the way I put it was we have there was our prediction interval. And it depended on what X we were talking about here. Let's read through this problem for a minute. These are new vehicle sales, and they show Toyota and Honda in sales. These are given in thousands, so keep that in mind when we write our final answer. All these things are in thousands. All right, so we have the new vehicles in sales in the United States for Toyota and Honda. So now we want to use the information that we have to construct a 99% prediction interval. The way you want to think about this, I think I've drawn the picture before, but what we're going to have is 99% will be in here and here. The other 1% will be split. So this is 0.005, 0.005. Let me just make sure I have 0.99. Yes, I think I have that right. So to get this cutoff, this here is our T sub C. Let's use the calculator for that. Remember, whenever you want this, you want an inverse T. So we're going to go to our distributions, that's above variables, and we'll choose number 4. And now we want this to be 0.995 is what we want. And there was 11 pieces of data, so we actually want 11 minus 2 for our degrees of freedom. And I've got to watch. I've been caught many times with this pressing the wrong minus. Got you. And then we'll enter our way out of this thing. And it looks like if I do 4 decimal places, I get 3.2498. 3.2498. So now when we're going to construct our E, it looks like this. We have a TC times an S sub E times 1 plus 1 over N plus N times X naught minus X bar squared all over N times sigma X squared minus sigma of X squared. Now X naught will be this guy right here. So we have 3.2498 times, where's our S sub E? 55.6076 times square root 1 plus 1 over 11 plus 11 times 2359. Remember, our data is given in terms of thousands, so I don't have to include 3 zeros at the end of this thing. Minus, now X bar I haven't grabbed it yet. Let me see if I can find it. It's easy enough to get if if you don't have it. All I got to do is go to Stat, Calc, and I got to just do 1 variable stats. You can do 2 variable if you just want, but I'll just do 1 because all I need is the X bar right here. My X bar is 2183. Got to square that. And then below we have 11 times. I have found that it's easier. Well, it depends. If the data is small, I just write it in. Let me see if they have the sum of x squared. See how big it gets? I think it's a pain in the butt to write all those things down. And then you have the sum of x, that quantity squared. I don't like it. So, well, I'll do this then. Let me compute that thing. I'll get it to 4 decimal places like the rest of them. So do the, well, you got to quit first before you do this. So we'll do the square root of 1 plus 1 divided by 11 plus 11. I can start a parenthesis. I have 2359 minus 2183. Let me finish that parenthesis. Square that. Now the bottom of that fraction I'm going to encase in parentheses just to make sure I have all of it. If you don't do that, you're not going to have the right answer. Now, what I need is to put this here, this sum of x squareds. Well, believe it or not, it's easy to find. If you go to vars, look at number 5, choose 5, and then move over to this right here, to the sigma, and there it is. So I'll choose number 2, and it puts it right there, minus. Now I'm going to put in its own little parentheses, I'm going to put sum of x, so that's the same place. Go to 5, go over to sigma, and choose number 1. That's sum of x. So I'll click number 1, finish off that mini parenthesis, like so, finish off the denominator, and I have everything I need. It doesn't like my syntax, and that's probably because there is a negative where a minus should be, as I'm quite... So I get 1.0577. And let's go ahead, and you can, to save yourself a little bit of time, I notice that I can just say times, and then I can put in these other numbers. And then enter. Now I'll finally round it to 3 decimal places since I'm getting ready to answer. 191.141. There. Now, how do we construct our interval? Well, this 2359, I have to plug it into y. So y hat will equal, let me see, where is my y? 0.460x and the x was 2359. And then what did I have left? Plus 410.839. And let's go ahead and calculate this. Alternatively, you could have put y1, put the equation for the function into y1, and then did what I did before, where you store a value into x and evaluate it. Here we're going to have 0.460 times 2359 plus 410.839. So I get 1495.979. Now we're ready for our interval. Our interval will look like where's our e? It'll look like y hat minus e is less than y is less than y hat plus e. So my y hat, I have 1495.979 minus 191.141, and then we have 1495.979 plus 191.141. And then all that's left is to calculate these numbers, and we'll have what we're looking for. So let's see, 1495.979, try that again, 979 minus 191.141, enter, 1304.838, then we have 1495.979 plus 191.141, 1687.12. These are in thousands. Keep that in mind. So our interval looks like that, or another way of looking at it is this way: 1304.838, comma 1687.12. Either one of those should be fine. Toyota has sales of, and how many, that was my X naught. Let's see if I can find that. That was 2359, I believe. There it was. Yes, 2359 has 2359,000. Then Honda will have between 1304838. Remember, these are in thousands. And 1687120. So then Honda will have between the 1,304,838 and 1,687,120 sales. And we are 99% confident in that interval.